Hello, everybody. Thank you for joining. My name is André de Ceuninck, and I work at Logic Technology, responsible as a Mindmotiv product manager. And my focus are our software quality solutions. Today, we are discussing the software process related to achieve functional safety with model-based development techniques. For this presentation, we invited some Mindmotiv partners who will share some use cases from the front line of embedded systems development and testing. We hope you find this information useful for your own situation, and we look forward to provide you hopefully some new ideas to take home. Let me introduce you Philip Meyer. He is one of the co-founders of Mindmotiv. He's in the session too. And as a first, I will present and introduce you our partner, Mindmotiv. And then Philip will take you through discussion with some guests who are using our test already, and they will share some of their experiences. Okay, so Mindmotiv started as a research project with the Ford Motor Company out of the university in Aachen. The goal was actually to improve the software process along the V model during the entire software lifecycle, which those days, when it started, was 2013. It was still a pretty fragmented process. And I think for many people, it still is. 6 years later, the Mindmotiv company was established out of that research project. So by now, they became specialists in providing solutions and services for efficient model-based embedded software development and testing. Customers are mainly in the automotive, aerospace, and industrial automation domain. So these customers were the early adopters of model-based techniques, and they wanted to benefit from the advantages of the technology, which is now very common in the industry. So Mindmotiv provides a signal-based test platform to perform functional safety tests from the model down to the hardware during the entire life cycle of the model, of the product, to support, for example, the automotive SPICE process. But they also help you to create norm-compliant systems according to the ISO 262 standard. You might be aware that all these standards are different, but they share a lot of functionality. So they are depending on each other, and the IEC 61508 was probably the first standard in that domain. So they include recommendations when it comes to testing, and they are very similar. Model-based development starts with the requirements. From there, the architecture of the system is defined and decomposed. So finally, software functions can be implemented in a model. From this model, usually code is generated automatically. And that code is also handed over to the hardware and tested. So finally, the complete software system is integrated and embedded on the target system for end-of-line testing. Every of these steps during the development, which is actually the left wing of the V model, there is a matching validation activity that has to be taken care of. And that is prescribed in the V model. So safety standards and all the derivatives like the IEC 61508 define the quality objectives of software and make sure you perform all necessary activities when it comes to testing in order to comply to this standard. Now, the problem in the industry is that it is difficult to translate these clearly defined, this process, which is clearly defined, into a consistent development and test activity. So that's why this process is usually very fragmented, because every step requires specific skills from the people who have to do this, and they are usually working in different teams within the organization. Some of these teams may be even abroad or not in the same location, which complicates things. And that is exactly the pain point that our test addresses. So it provides a test framework that includes a test specification language and instant visualization functions. By this, it reduces the test development effort and assures reusability of tests that were created early on during the design of the model down to the end-of-line test. Safety standards recommend requirement-based testing. So our test analyzes the model and allows to specify test and acceptance criteria. As I already mentioned, this live preview, this instant signal preview, is the best way to understand what you are describing. And it helps you to translate the requirements into test scripts. Our test will automatically implement these tests and execute them at the required level. So that can be on the model level or at the end of line test or during a hill test. Test results are very well documented in various reports. This simplifies the process again for the test engineers, and they can focus on translating the requirements into test cases for validation purposes. Now let's have a look at some real-life use cases. Philip, can you please go ahead and introduce our guests?
Yes, thank you, André. First of all, thank you all for joining. 30 minutes, of course, is a very short time to dive into something as complicated and complex as model-based design and testing. So what we would like to do in these 30 minutes is we have asked some of our partners and customers to give some exemplary use cases that they use in their respective companies. And we hope that these are sort of inspirational to get a good feeling about what is possible when we talk about state-of-the-art model-based design and testing, and how quality assurance can work over all different development levels. So, and of course, if you would like to get in touch after if you have more questions, feel free to ask them in chat, and then we will try to answer them now or maybe later. So the first guest that I would like to introduce is Mr. Lars Posdena from VEMAC. Lars, please go ahead. I saw him in the... there we are.
Yeah, there we go.
Great.
Thank you for the introduction. I'm going to make a short introduction what we do with ArtTest in our company. First slide presents a little bit what we do in our company. VEMAC company is founded in 1999, so we are already 22 years on the market. We started as a test bench engineering company with a real combustion engine test bench. It's still in use, but then we took over a little bit to electronic development, software development, engineering services for all purposes. Our first customers come from the automotive world, and now it's a little bit mixed up. We have automotive clients and non-automotive clients. And during our engineering projects with our customers, we developed a lot of tools by ourselves. So we are offering rapid prototyping ECUs, brand new calibration tool, which is a little bit different from other calibration tools, and so on. And that means what I want to say is, everything. As a typical small company, we are 20 persons. We don't know which projects we are going to meet tomorrow. You know, over the time, we had a lot of different projects, different topics, and so on. And that is basically the reason we like ArtTest as a tool, which is very flexible in terms of fitting it with the customer requirements. So go to the next slide, please. So here's a typical hardware development project for customers. So we are starting with our own tool. It's the next slide. Now this slide shows a little bit how we use ArtTest during our development process. So we're doing mill, sill, and hill with it. But we will see later that in between there are a lot of Twitter solution between mill and sill or sill and hill. This is because during the project we are there are challenging gaps. So the customer, which is basically responsible for the software on our prototype system, hasn't built up the software, but our safety software in this project, for example, we are doing safety software and interface software. So we have to test it before the real software is ready. And so in a lot of cases, we are doing something between the here shown arrows, mill and sill and hill. So let's see on the next slide, the typical projects. No, this is the, this is already the end of line test here. So if we are ready with our process, development process for our customers, normally he asks us, how do we stable quality and safety functional safety in our production process, and so we built him up an end-of-line tester based on the same software we used all the development process, and this is art test. So we use it from the cradle to the end of the project, to the ready product. We use art test as a preferred tool for testing. So, and then next slide. Here some information. We found out, Mindmotiv and VEMAC together, that our tools are very similar. We are responsible for calibration in this development process, and for the hardware and software development systems. And art test is our perfect testing tool that fits with different customers, with different project types, and so we decided to put all into one box and start to sell this package of products together with Mindmotiv. This was the last slide, I think. And so I'm ready for questions.
So I don't think we have any questions in chat right now. So maybe what I would, I had a question. You showed on your slides, you showed this custom test bench with back-off terminals. Have you considered any other like traditional test bench vendors, for example?
Actually, we're using back-off terminals also at every stage of the development process. So we make small hill tests during the development process, for example, and we prefer back-off terminals because they use an open standard, Etherlab, and this is it's a solution for a smaller budget, and first of all, it's more flexible for us to use back-off.
There's a question from the chat. Do you use formal verification in the design process?
Can you define the question a little bit? So I come from electrotechnics, so sorry about that.
Hello, can you hear me?
Yes.
Yeah.
Okay, great. So basically, it is because you mentioned about safety and specifications. So formal verification is about making a mathematical model and then guaranteeing that the model satisfies your specifications. So it is a specific mathematical way of verifying that your model satisfies your specifications. So I was just wondering, because safety is involved, whether it is the case that you consider that.
Norbert, are you listening? Can you answer this? Because you helped us setting up in the last project the
Yes, can you hear me? So ARTES is able to control formal verification toolboxes, for example, if they are provided by MathWorks, so we can use the design verifier or static analysis. This is what we can automate in the testing process.
Okay, thank you. Great question. If you have any questions, if you want to go into this deeper, feel free to contact us anytime. So I think we should now continue for time reasons because the organization cuts us off at 30 minutes. So yes, I would like to introduce Mr. Lars Anderson. He's a representative from BPW, and he will show us some more use cases that are, of course, interconnected with functional safety, but that are quite different from what we've just seen.
Yes, thank you for your introduction. My name is Lars Anderson from BPW Bergische Achsen KG, and we are founded in 1898 in Wiel. That's a small town in Germany near Cologne. And we have sites in Europe, Asia, Africa, and Australia. In specific, there are 8 development sites and 16 production sites in over 20 countries. And our core competences are around truck trailers. For example, axles, brake systems, lighting, body structure technologies, or telematic. And these competences are divided between the BPW and its 4 subsidiaries, which all form the BPW group. And in the whole group, there are 7,300 employees. And 30 of these employees are working with me in the business unit electromobility. Our aim is to create a full electric axle for trucks. And it began as a project in 2012 and becomes a business unit in 2015. And the current vehicle mass we are focused on is 7.5 tons, but we have concepts up to 40 tons. And the product we develop is not only the axle, but the whole system. There are batteries, onboard charger, drive and charging controllers, cooling systems, displays, and the high voltage network. And we develop the software for the drive and charging controllers in-house. So we have to test the software. That's my task. And can we slide back, please? And the first step we did was to give the Mercedes-Benz Vario a second life. You see the Vario in the bottom right corner. It's a retrofit, and the conversion is done by Paul Nutzfahrzeuge. And now it's not a Mercedes-Benz Vario anymore. It's a Paul Vario. And we have 50 vehicles in daily use. 2 of these vehicles are working in 2 shifts. And the most customers are cities with special vehicles with expensive superstructure technologies, like shown in the photo. And our current step we're working on is to electrify a glider chassis from an OEM. In this case, it's Isuzu. And we want to become a tier 1 supplier. And for this, we want to adapt our system to new vehicles with more modern technologies, like assistance systems. And therefore, we have to develop with the ISO 26262 and IATF 16949. So we must rework our developing tool chains in our workflows. For example, software testing in the past was by executing self-scripted MATLAB scripts and Excel sheets. And now that we had to comply with the norms, we use RTest. And on the next slide, you see our workflow. Our main aims by testing is the traceability of the tests in relation to their requirements. We write in Polarion, and the reporting of the test results back to Polarion to track bugs and defects. And as you see here in the slide, RTest is the central tool for the testing workflow. First, we're getting the requirements from Polarion as an update. Second, we start our tests. You see mill and fill tests, we start via MATLAB script and Simulink. And hill tests, we testing with DSpace Galaxio system. There are two different ways for mill and fill or for hill. And the last step is the evaluation of the test results and committed back to Polarion for further processing. In my opinion, the top advantages of RTest are the quick and easy creating and debugging of tests with displaying the signals live. In the left bottom corner, you see a screenshot of RTest, and there on the left side you write tests, and on the right side you see the signals live as in a diagram. The second advantage for me is the perfect fitting in our tool chain with the tools Polarion, MATLAB, Simulink, and DSpace Galaxio. Furthermore, we have confidence in stability and working correctness of the whole testing process. So we can be compliant with the two norms. And last point, the opportunity to improve RTest for our needs. So we send feedback to Mindmotiv, and our wishes will be fulfilled. If you have questions, you can now ask.
I think, I don't know if people have been following chat. There are some questions already in the chat. I will quickly recap them. So there was one question, is RTest available to do ISO 262 and ASIL level D? Yes, we provide a qualification kit to also perform ASIL level D tests. And second question was answered before, I think, in the presentation. So we offer support for multiple requirements tools. You just heard BPW say they use Polarion. We also, of course, provide different importers and exporters from let's say basic CSV files for raw data import, for example, and up to like Excel and professional requirements tools. Another question was, can the tests be reused in different steps of the software development process? Absolutely. So with a test that is defined in our domain-specific language, RTest, we are able to perform a test from the model level to basically the end of line. So if you have a test that you use on the model level, you can reuse it on ZIL, on HIL, on integration tests, on every kind of test you would like to perform, as well as perform an end-of-line test. Yeah, and as you saw, for example, at BPW, the test bench of choice is Galaxio from DSpace, probably well known. VEMAC uses, for example, backup terminals, which also perform most of the functionalities of these based systems, but of course on a much smaller budget. So this is something that we also want to make sure that the test cases can be reused, not only like level agnostic, but also platform agnostic, which of course makes it very easy to do a full quality control and to test early on in development, which of course is a lot cheaper than testing only Hill, for example. Yeah, great. Thank you, Lars. Thank you both, Larses. We are already approaching the end of the session, so I would again invite everybody who's in the session now. I think we are not bound actually by these 30 minutes, so if you would like to discuss further after the session, please feel free to get in touch with André de Ceuninck or me during the trade show, during Embedded World or afterwards. So I think we will be able to contact each other. I brought you two last use cases from customers of ours who sadly were unable to send Lars as well to the presentation. So I will quickly go over them. Maybe if you have any questions regarding those, we can also talk about them later. One is FKA, who is a classic testing services provider for large OEMs. They mainly use our test on Mil-Sil testing, so Mil-Sil back-to-back, and of course, what FKA was mainly interested in was a seamless integration with the infrastructure and the requirements of the OEM. So this was possible with our test because we do provide the ability to perform all kinds of tests on model and software level, especially advanced tests cases like fault injection, internal signals, black box, white box testing. That is all supported. And because the test cases themselves are basically text files, the integration with the infrastructure of the OEM was also very easy to do. And finally, basically from the different side, a large OEM, like one of our largest customers is Ford Motor Company. There, of course, we are talking about different challenges. So, of course, Ford has multiple locations around the globe, and all these locations work on this big project that is called functional safety. So what we provide with our test to Ford is mainly apart, of course, from the functional safety excellence, the ability to interconnect their testing efforts from model to hardware. And we even are working with Ford on a solution to better utilize hardware resources that are used in testing, so Hill testing, that of course are quite expensive and usually not used at full capacity. But this is all I can say about this right now. So yeah, I think this is sort of a full landing or perfect landing. I saw there was one other question in chat. The question, okay, just got a pop-up here. Yeah, I think the answer is already there. I don't know, Lars, would you like to answer this question?
Yes, the question was of if we only use Polarion for requirements and not the integrated module of R-Test. We at BPW only use Polarion because we had Polarion before R-Test and don't want to switch. So our requirements are only in Polarion.
Okay, perhaps might I just the question of my or the part of my question was, I'm here, Susan speaking. I'm Polarion pre-sales consultant. My question was because I mean in Polarion you also do have like integrated an integrated test module. So my idea was to use also the testing module in Polarion to have the full traceability from the requirements to the testing based on the test results from our test. Or do you see, or is there any traceability between the requirements in Polarion and then directly to our test results? That was my question basically.
So maybe last.
If I understand the question right? You want to know if the results go back to Polarion.
Mm-hmm.
Did I?
Yeah.
Yes.
Yeah.
The interface between Polarion and R-test, there you must ask Norbert, but you can get the requirements from Polarion via an update if you like, and the test results after the run will be committed back to Polarion so that you can build the defects in Polarion and can start the change request process.
Okay, so that means you will also have like the test cases in Polarion, so they are linked back to the test results from R-test, right? So that you can have the direct automation creation of the defect, link this back also to the requirements, so that you have the full traceability on your V model. Is that right? Did I understand it right? Okay,
yes,
cool.
Exactly.
Okay, nice. Thank you.
Yeah, thanks for the question. Great question. So, of course, traceability is a big issue, especially if we're talking about these process gaps from model to software to hardware. And of course, tracing that back to the actual requirements. So this is something that we are very adamant about to provide. So we do make the full round trip between requirements and test results. So this is something that we are very keen on providing, which is why we selected BPW as an exemplary use case, because they do it very integratedly. Okay. If there are any more questions, I would be very happy to answer them. Otherwise, thank you for attending. Thanks our guests, Lars Posdena and Lars Anderson. And I will give back to our master of ceremonies, André. Thank you.
Yep. Thank you, Philip. Well, thanks to everybody for joining, especially to Lars at VEMAC and Lars at BPW. It was for sure very interesting for people to understand how others do it, and we appreciate your availability and your will to share your use cases with us. Of course, we discussed the risk and solutions, so I hope R-test, some of you have a closer look at R-test and get back to us to improve your process when you do model-based system engineering. And yeah, I think time is up, so thank you very much. If you haven't signed up, we have some more sessions during the week at Logic Technology, so come by at our booth. We are available all day, myself and also Philip. Even if it's a virtual world, we do what we can to help you. And I'd like to thank you again. And hopefully next year we can have this kind of talks live, face-to-face at the stand in Nuremberg. And hopefully we have some nice dinner and meals later in the evening. So hope next year everything is back to normal. So thanks everybody for joining us. Bye.